Hey YouTube, welcome back. Today is the 8th or 7th basically video of our series of the system design fundamentals. Um, I will before I go to our main topic, it will be the stateless web tier. I will just make a small uh, uh, review of what we have building here. Basically, we are building our end of this series basically is to build a scalable system design. So let's just start from the beginning. We have the client. The client wanna connect it with the backend. So basically, the client access the load balancer IP address from a domain name system service. It's provided by third party. Basically, by sending the domain name, the DNS send back the IP address, and the client connect with the load balancer with the IP address with the HTTP protocol. And basically, the load balancer works as a middleware between the client and the web tier, and basically it just distribute the incoming request from multiple clients to a specific web server, and make sure that we all of the server have even request. There is no server has overload. If one of our servers went out, the load will like fell down or something like that, the load balancer will continue send requests to the other servers, the other servers that are working basically. So we'll make sure that we has maximum availability, we have maximum scalability, and also by distributing the request, that we make sure that our user doesn't wait that much to get its response, so we have better user experience. And yeah, in the web tier, we scaled our web server, so we used multiple web servers instead of just scale up basically, and add more memory. By adding more memory and CPU, we maybe have two problems. First, it's quite limited, we can't add RAM until end. The second is that we have only web server, so we have a problem with just a single point of failure. So basically, we created multiple web server, and we just, if we had increasing in requests, we add more. If we don't have, we can just shut the web server that we actually created, and the load balancer handling routing the request to a specific web server, to make sure that there is no server taking too many requests than the others. And if there is a server is not responding, the load balancer will know that, and route all of its requests to the other servers. So, and basically, the web tier connect with the data tier. Basically, we have our own database here. We have a master slave architecture. Basically, the master has all of its write operations, and the slaves has all the read operations. And when the master has a write operation like edit, delete, or add, it send the copy to the slave. Basically, in this architecture, we make sure that we have maximum availability and maximum reliability. And also, if one of the slaves went down, the request will be, we have one slave that will continue working. If the master went down, one of the slaves will be promoted to be an actual master. And also, if because we have two, or maybe we can add more slaves that support reading operations, the reading operation will be quite more faster and way more efficient. And basically, we had here to make sure that we are not to make sure that we and after that we solve the scalability. So right now we want to solve the latency. So basically, we build a cache. And a cache, basically, it's a memory storage that we use the frequently access data, and to make sure that before we access we request data from the database, we make sure if it's in the cache or not. If it's in the cache, we'll just take it right away. If it's not, we will take it from the database and we store it in the cache. And when you have a cache, you want to make sure that your expire policy is not too short, and also it's not too long, to make sure that your data as well as possible. And last, we have built a CDN, and basically to store all of our basically to store all of our images, our static content, and like for example the content delivery network. Basically, if we are requesting like an image for specific server, and this server like just like 3 or 4 5 kilometers away, we request it, and after that we store it in the CDN. The CDN, it's geographically way more closer to the actual client, to make sure that we have way less latency. And yeah, this is it for now. And what we are going to build right now is that we have something called a stateless web tier. Right now, our web tier, we want to make them stateless. So basically, if the client connecting with the web, so basically if we had, okay, I will just make here, just add, let's just add client, and copy this client multiple times. What? Oh, sorry. And sorry, and delete. Oh, sorry for that. So basically we have this client, and we want to copy this client, and yep, we have this. We have 3 clients, and we have I want to make the color different here, and it will be, and the server also I want to make the color, and okay, so we have this 3 clients, and we have 3 servers basically, and basically for each client is connecting with a specific server. Let's assume that, and yeah, and basically each server, because each client is connected with each server also stores oh no, it's too big, and the thing that yeah, let's see, store the session data, session sorry, the session data of the user, and maybe maybe profile image, or like yeah, maybe profile image, and no, so basically when the client is connecting with a server, each server right now, this is what we have, it's called a stateful architecture. Basically the stateful architecture remembers the client data, and from one request to the next request, and actually so basically the server could handle the client, and could basically send to the client the right data based on its session data basically. And basically and basically we want to authenticate the user, something like that, or just want to get the image of the user. So basically we use this session data, maybe we are storing its token, something like that, and we just take the token, and we store it in we send it to maybe like to middleware to get the actual user, things like that. And basically the problem with this architecture, if basically the request is sent to basically to another server, for example if this client send the request to other server, basically this session data is not like this session data, they are not the same. So what will happen, that this will fail, okay? And the other thing, that if one of the servers went down, this client can't access the server anymore. It needs we needs to store a new session data for it, because its data is quite gone. So basically, it's quite hard when we work in scalable applications with a stateful architecture. What is a stateless architecture? The stateless architecture has two ways of working. Basically, it's first, what is a stateless architecture? A stateless architecture, basically, it's a design pattern that used in the backend of the web application, in the web tier, basically, that basically treats each incoming request as independent. Basically, we don't store any state in the actual observer. But how can we access the state? How we can just, let's say that we have session data of the user, how we can have this session data? Basically, we have two ways. First of all, the client will send us the session data. Maybe the client will store the user's data in maybe like its local storage and send us the token, and we just, yeah, and the backend doesn't have to have any session data. It will be full stateless. Or we can basically we can basically store our session data in shared store. For example, we can just has like let's just add, just get this one and put it here, but I want to change the color. Let's make the color, it's maybe like we can store it in NoSQL database, or we can store it in a minute. Yeah, basically what we can do right now, maybe we want to store the actual users data. So basically we can store them into NoSQL database, and basically in the system, and or we can store it into memcache Redis database or like relational database, but we choose NoSQL because it's pretty easy to scale. It's really easy to scale. So basically, in the stateless architecture, the HTTP request from the users can be sent to any web server for this one. Basically, because any web server will take the request, and instead of reaching its own session, it will just connect with the NoSQL database to know if you have the user token or something like that. And basically when the HTTP request from the users can be sent basically to any web server, which fetch the state data from the shared store from this NoSQL, basically from this NoSQL store. The stateless basically is way more simpler, and it's more robust and more scalable basically. And basically, when we move the session data out of the WebT and store them into persistent data storage store, basically the shared data store could be relational database if we want, could be memcache if we said before, could be NoSQL. Basically, we choose the NoSQL for this one. It's pretty easy to scale. The auto scaling, like, it means like adding or removing web servers automatically based on the traffic load, something like things like that. After the state data is removed out of the web server, it's pretty easy to handle all of the auto scaling. So because of that, we went for the NoSQL, but feel free to use SQL if you want. Like it will also work, but NoSQL could work better in this specific example. And that's it for today's video. And I guess we maybe have 4 videos before. After that, the next one will talk about the data centers, basically how we use the data centers. After that, we're talking about the queues and the logging, and after that we talk about the database scaling, because it will be quite important one. And I guess that's it for the series. Basically, if maybe you have 4 or 5 videos more, and if you like this video, make sure to subscribe to the channel and give me a thumbs up, and see you in next video.